A voice agent that answers too early or ignores interruptions feels broken. LiveKit turn detection and Silero VAD make it wait, respond, and yield naturally. You'll see how to connect the pieces into a workflow that detects speech, decides turns, stops interruptions, and reports cutoff and delay signals. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Live voice systems fail when they guess the wrong finishing point. Users pause to think. They cut in to correct the agent. Without good turn-taking, the conversation turns awkward and slow. LiveKit, voice turn-taking and interruption, is about making the agent behave like a polite human who listens, waits, and yields. That same logic reduces user frustration and measurable complaints in trials. At its core, we want two signals. One is where speech actually is. The other is whether the speaker intends to yield the floor. Together, they stop early replies and allows safe barge-ins. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We start by wiring audio boundary detection into the session, so the rest can assume clean speech regions. This snippet loads the LiveKit Silero VAD object that marks speech versus silence. It gives us a reliable speech silence feed via silero.vad.load. So agent session gets a ready-made VAD instead of us hand-rolling detection. That shared VAD object simplifies everything that follows, letting later code focus on turn logic rather than audio plumbing. And the printed output confirms the LiveKit VAD is ready before we tune endpointing or interruption policies. Silence is not the whole story. We next add a semantic turn detector, so the system guesses intent behind pauses. This example adds LiveKit semantic turn detection to the voice pipeline. The turn detector gives agent session a second opinion. Not just is there audio, but does this pause look like the user is finished? Turn handling options wraps inference.turn detector. And agent session combines that with VAD, STT, LLM, and TTS providers. In short, VAD finds speech regions. Turn detector helps decide whether to take the floor, and the output shows the active detector class, so you know the guard against premature replies is in place. Now, we tune how aggressively the system waits after a pause. Static timeouts feel brittle, so we make endpointing adaptive. This code makes endpointing adjustable, while the LiveKit agent session is already running. It applies session.update options, endpointing ops equals endpointing, to swap in a dynamic policy with a bounded min delay and max delay, so waits adapt to recent behavior. The pauses list is a tiny monitoring sample, and wait is a local estimate you compare against observed pauses. Lowering alpha makes the system react faster. Raising it smooths changes. The printed wait estimate helps you balance responsiveness against false cutoffs. Barge-ins need their own safety rules. We want true interruptions to stop the agent, but not every noise or micro-utterance. This snippet configures LiveKit interruption handling, so the agent can stop for real barge-ins without overreacting to noise. The interrupt dictionary is set to adaptive mode, enforces a minimum duration, and requires at least one word before treating speech as an interruption. False interruption timeout gives the system a short window to confirm intent, and resume false interruption lets the user continue when the cutoff was mistaken. Rebuilding agent session with these turn handling options makes the policy active, and the output shows recovery is enabled. Exactly what you want, so the system can correct mistaken cutoffs. Finally, you need metrics and hooks, so you can watch when the system makes mistakes and how long replies take. This example turns turn-taking quality into counters you can watch during incidents. The session.on agent false interruption hook increments stats when the agent realizes it stopped for a false interruption. And session.on conversation item added reads ev.item.metrics to capture E2E latency from completed assistant turns. The seed list provides deterministic examples before real traffic arrives. In production, those same handlers feed live metrics. Together, they give you cutoff counts and average response delay, so regressions are measurable. In a full deployment, these pieces map directly to operational checks. VAD errors show as misaligned speech windows. Turn detector misfires show up as false interruption spikes. Endpointing drift increases average end-to-end latency. Use the same event hooks to populate a dashboard and set alert thresholds. What this gives you, boiled down. First, it is a small pipeline that pairs Silero VAD with LiveKit turn detection to make polite voice agents. Second, use it when you need low-latency assistant replies, but also safe barge-ins in conversational interfaces. Third, watch out for domain mismatch. Models tuned on short commands can be too eager for long, thoughtful speakers. To move this further, tune the endpointing alpha and the min delay on a recorded validation set. And track two metrics, false interruption rate and average E2E latency. Adjusting alpha changes how quickly the wait estimate follows recent pauses, and min delay sets a safety floor for thoughtful pauses. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.